Good morning, my dear students. Okay, continuation of that discretization process. Okay, so in the last PPT, I told the first one. Okay, what is the different types of element? Okay, and which are going to use for the analysis of finite element method. Okay, now here we are going to use the continuation. What the second stage, that is the size of an element, number of elements, and location of node and node numbering scheme. Okay, in the this is the second part of that. Okay, in the first stage we studied about the first number one, that is the types of element used in finite element method. Okay, so here we are going to use the second the second, third, fourth, fifth steps. Okay, what is the importance of size of an element, and how what we are going to call as which element we are going to call as number of elements, how we are going to divide that element. Okay, on what basis. Okay, and the location of node. Okay, how you are going to denote or denote the nodes in a finite element analysis, and how you are going to give the node numbering scheme as in a longer side or edge, shorter edge. Okay, that you need to study about this in this class. Okay, so here I told you that discretization process is different, and the finite basic steps involved in that is different. Okay, so discretization process means 5 steps. That is the first one is types of element, second one is the size of an element, number of element, location of node, and node numbering scheme. Okay, let me understand this to second one. Okay, first one is over, now second one is size of an element. Okay, look at this diagram. So let us assume a plate with a hole. Okay, this is a geometrical model. Okay, we want to calculate where is the maximum stress and where is the minimum stress. Okay, in the analysis part. Okay, what is the first step? To divide the small pieces. Okay, so here we are in the figure B shows what the divided element. Okay, small pieces. Okay, look at here. So okay, hole will be there. So with the help of this we are going to calculate the maximum, where is the maximum stress and where is the minimum stress. Okay, with the help of some formula. Okay, so that is the important of your size of an element. Okay, if you divide the more number of element, it gives a more accurate result. This is the main concept behind this size of an element. Okay, types of element we already studied, that is 1D, 2D, 3D elements. Okay, the size of an element means what? The size of an element chosen in a finite element model, because the size of an element influence the convergence criteria. Okay, this convergence criteria will tell you. Okay, the convergence criteria. Okay, of the solution. Okay, if the size of an element is fine, that is a very small piece, then the final solution is expected more accurate, but at the same time we have to remember the use of the finite element mesh. Okay, will also more mean computational time. Okay, so if you divide the more element, that process is called as a mesh. Along with that we are going to consider this also. Okay, fine mesh will also more computational time. Okay, time is also very important. Okay, as far as possible we have to use the same size of an element throughout the body. Okay, but sometimes we have to use the different size of an body in different cases. That is little complicated problem. Okay, so let us assume for an example, in a case of stress analysis. Okay, plate with a whole element. Okay, the size is as shown in the below figure. Okay, because of the stress concentration and is expected, and also the size of an element is too very small near to the hole, because here the maximum stress will be there. Okay, this size of an element that affect the finite element model solution is the special ratio of the element. Okay, so the main concept behind this is the size of an element means if you divide the more number of element, you are going to get the more accurate result. You have to remember in this slide. Okay, that is size of an element. Okay, so here we are going to calculate the stresses and strain, where is the maximum stress and where is the minimum stress. Okay, with the help of software. Okay, now coming to the third one is the number of elements. Okay, how many elements we are going to used in finite element method. What is the importance of element? Okay, why it is the importance of dividing the element? Okay, that we need to study here. Okay, the selection of a number of elements in a finite element method is treated as the size of an element. Okay, and it also involves the degree of freedom in it. Okay, so if you divide the more number of elements, more degree of freedom will be there. Okay, so that is also to solve that is also a little difficult. That is a complicated. Okay, the more number of elements gives a more accurate result. This I already told you. Okay, but along with that we have to but there will be a certain number of elements beyond which the accuracy can be improved. Okay, so now this behavior is shown in the below figure. Okay, that means we have to remember that the use of large element will also mean a large number of degree of freedom, more computational time. Okay, more computer memory required to store the data. Okay, look at here diagram. Okay, so this one is a no significant improved beyond no. Okay, so here the exact solution. Okay, so accuracy number of elements, if you divide the more number of elements. Okay, so here the solution obtained from the FA more accurate result will be there. Okay, so okay, like this curve will be shown. Okay, more accurate near to that. Okay, not accurate, near to that we are going to get the result. Okay, so here you have to remember, if you divide the more number of element, you have to consider the degree of freedom of each node of all the element. Okay, that is also very important in this slide. Okay, now coming to the fourth one is location of node. Okay, so node is nothing but what? It is a point or it is a joint. Okay, so node is a point where the properties are defined. Okay, what is how many degree of freedom will be we are going to define, that is what the property. Okay, node is a point where the properties are defined and determined for an element. Okay, and the location of node is very important in finite element method. Okay, if the body has a discontinuity, such as a discontinuity in a loading or geometry, material properties, these nodes are introduced. Okay, where to introduce nodes, where the discontinuity will be there, where we are going to introduce nodes. Okay, I hope you understand this. Okay, where we are going to denote the node, where the discontinuity will be there in the geometry or a given problem, where we are going to adapt the node. Okay, so look at here the diagram. This is a just example. Okay, so point load on the beam, so one end is fixed, another end is force is acting, so here a node will be introduced because here point will be there. Okay, so you have to introduce here nodes. Okay, again coming to the second diagram here, so this is a this is what discontinuity in a loading. Okay, so here the load is different, here load is different. Okay, but we are going to denote the node in between these two. Okay, so exact here, because the here the strength is different, here strength will be different, it will be broken, so where we are going to denote the node. Okay, this is common, 1 2 is common, in between we are going to denote the node. Okay, again here also. Okay, this is a stepped bar system. Okay, so here one node, two node, here the connected joints. Okay, here we are going to introduce the node. Okay, again here also, this is a heat discontinuity in material properties. Okay, so this is a copper aluminum plate. Okay, combination of two material. Okay, so here one force, two force, three force, 4 5. Okay, where force are acting, where you have to introduce the one node. Okay, that is the location of a node. Okay, that is that from this you are going to understand where the discontinuity will be there, we are going to use node. Okay, this is about the location of node. And last one is a node numbering scheme or method of node numbering scheme. Okay, this is also very important, node numbering. So they may ask you 2 mark or 3 mark question. Okay, explain node numbering scheme anta. Okay, the size of a global stiffness matrix resulting from the finite element analysis depend upon the node numbering scheme. Okay, so how many nodes you are going to use, and no numbering of a degree of freedom considered as per the node. Okay, we have simple formula problems here. Okay, we have to use the formula with a half of called as bandwidth or half bandwidth, which is formula which is equal to capital B or small b is equal to d plus 1 into f. So d stands for what, degree of freedom, and f stands for degree of freedom, d stands for largest maximum difference between the node number in the element. Okay, I will show you here. Okay, this can be explained by two methods. One is the dimension along the longer edge, and one more is the shorter edge. Okay, let me understand first problem. So this is a given plate. Okay, normally this is okay, so here the longer edge means here there will be two side will be, this is a longer edge, this is a shorter edge. Okay, so dimension along the longer edge. Okay, so longer edge you have to just you go on keep. Okay, just go on denote the number. Okay, so longer, consider longer edge, this longer edge, and just use they are given 1 2 3 4 5 6 7 8. Okay, 8 column is given. Okay, so just to give the longer edge side no numbering, that is because here discontinuity will be there, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 17, like it up to 54 you have to give the longer edge side node. Okay, so how to calculate the bandwidth here for this? Okay, so how to calculate the bandwidth here? B is equal to what? B is equal to this 17 plus 1 into 2, this is 36. How we what, we have the formula what, d bandwidth B is equal to d plus 1 into f. Okay, so d stands for largest difference between the two node numbering element. One is the degree of freedom, f is the degree of freedom. Okay, so this belongs to 2D problem, so each for 2D problem degree of freedom is 2, so you have to write here, this is a d plus 1 into f 2, this degree of freedom is 2 because it is 2D element, and large d 7, how you got 17 means d is the maximum largest between the two nodes, so maximum largest is 54, on the longer side means 37, 54 minus 37 is equal to 17, so half bandwidth is equal to what, 36, like that you have to calculate the dimension along the longer edge. Okay, similarly shorter edge. Okay, again here this is the longer edge, this is the shorter edge, again same 1 2 3 4 5 6 7 8 9, go on give the node numbering where the joint will be there for the shorter edge side. Again formula is B is equal to d plus 1 into f. Okay, again it is a 2D problem, so f is equal to 2 and d is equal to what here, 11. Okay, 54 minus this what, shorter edge, so shorter edge is what here, this is longer edge, shorter edge, look at here, shorter edge is equal to this minus this, 11 is there, so 5 plus 6, how much, 11, you have to add here 11. Okay, shorter edge. Okay, B is equal to 11 plus 1, here we are going to add, where we are going to dot add. Okay, so 5, otherwise shorter edge, difference between the shorter edge. Okay, so 1 2 3 4 5 will be there. Okay, so which is the maximum here, maximum is 54, 54 minus 43, you are going to get the 11. Okay, 11 you have to write, B is equal to 11 plus 1 into 2 into 24, like this is the second problem, this is the first problem. Okay, like that you have to calculate the dimension along the longer edge side, no, shorter edge side for the node numbering scheme. Okay, so just to remember this, for the first I will tell you. So in the discretization process, the first step is what, here first step is types of element which are going to use, that is a 1D, 2D, 3D and axisymmetric element. Okay, size of an element means what, how you are going to divide, that is a meshing process. Number of element means if you divide the more number of element, you are going to get the more accurate result. Okay, location of node means what, how you are going to, where discontinuity will be there in the problem or geometry, where you are going to introduce the nodes. Okay, node numbering scheme means again there are two methods, longer and shorter edge side. Okay, you have to use calculate the node numbering scheme, that is the bandwidth formula is equal to what, b is equal to d plus 1 into f. Okay, by using that formula you are going to calculate. Okay, this is the discretization process involved in finite element method. Okay, so this is very important, but at the last stage this is very important here, node numbering. This is some simple example will be there. Okay, why don't here, one thing is there, here 1 2 3 4 don't come here 9 to 10 here. Okay, you come in the direction only the same way. Okay, after 9 you have to denote the 10 here only, not don't come here. Okay, so 9 10 11 12 13 14 15 like this. Okay, so d, here the formula will be there, d plus 1 into f, where d is equal to what, maximum largest difference between the 2 points. Okay, that is the largest here is what, 54. 54 minus 37 is equal to 17 plus 2 means f, degree of freedom, it is a 2D problem, so write down 2. Okay, like that you have to solve the problems. Okay, finite element method. Okay, so I hope you understand this discretization process in finite element method. Okay, thank you.